This video covers exponential functions day 1. So, some examples of exponential functions are over here on the left side. In each of these examples, if you notice, where's x? Well, x is in the exponent. So if x is not in the exponent, it is not an exponential function. Off to the right side, we have some examples of non-exponential functions. These two, x is a normal size, and it's just an x, not x squared or x in the exponent, so that is a linear function. And then anytime we have an x squared, that is quadratic. So exponential functions in standard form look like so, where we have a times b to the x, and this is not on your formula chart. There is nothing about exponential functions on your formula chart. So a, right here, the first number is your initial or starting value. It's also your y-intercept. So ironically, this a in your exponential is like b in linear. And then b is your base and also your rate, and x is your input. So we're going to look at these different pieces. So on this initial one, remember a is the number in front. So this one, a is an invisible 1. My y-intercept is 0, 1. And then b is the number with x. So on this first example, there is no number in front of that, so make sure you watch out for a's and b's and like sneaky a's. Okay, so for this next part, I'm going to come over here and I'm going to say that in this example, c is 1, which is our a value, and then our base is 3. Okay, so you can see down here at the bottom, this is what I'm looking at, 1 times 3 to the x. And so if we notice, our graph is going like this. If you can see, maybe I can make this full screen here. Okay, if you see here, there's like this little red dashed line. That's called an asymptote. We're going to talk about that in a second. But my y-intercept is at that 0, 1 because that's my starting. And then this graph is increasing. It's going up. And it goes up like so. Okay. So the next one, 1/3 to the x. Remember, we have a sneaky invisible a value of 1. My b is the number that's attached to x, so 1/3. So I'm going to come back over here and I'm going to change this to be 1/3, so that's like 0.3 repeating. And what do you notice about this graph? It starts at the same point, it has the same y-intercept, still has the same asymptote that we're going to talk about in a second, but this time your graph has flipped and now it's going down or decreasing. And our graph kind of looked like that. Okay, and to get to this website, I just scan this QR code. So for all of these examples, if you want to try something, you can scan that QR code and see what changes. Okay, so the next one, 2 times 3 to the x, so I'm going to bring this back up to 3, and then I'm going to change this to be 2. Okay, so if you notice, this one, just like the 3 to the x, is still increasing, but this time my initial value, my a value, has changed to 2. So my a value is a 2, my y-intercept is 2, and my b is 3. This one was still increasing, and it looked just like this one over here, but it starts a little bit higher on the y-axis. So if you notice, these are both increasing, but this one looks a little bit higher on that y-axis. So in an exponential function, we just saw if b, the number with x inside parentheses, if b is greater than 1, the graph is increasing. And I like to draw pictures so that I remember what it looks like. So it's increasing from left to right. If b is between 0 and 1, which was this option, it is decreasing. So instead of having positives and negatives, we have big numbers and fractions. So if b is bigger than 1, it's increasing, it's getting bigger, and if it's less than 1, it is decreasing. Okay? So notice in each of these examples below, as the graph approaches the x-axis, it does not cross it. Because of this, the x-axis is called an asymptote, a line that a function gets close to but does not touch. So for an asymptote, you can imagine it like a couple different things. One most obvious that a lot of us can relate to is the friend zone. If you like somebody, you guys are getting closer and closer. So like let's say this is your relationship here, you're getting closer and closer and closer, and then they say, oh, I just want to be friends though. So you get real close to being with them, but you stay right on this friend zone line. You never cross that line because you're just going to be friends for the rest of your life. Just like this graph never crosses that line. So that asymptote is a line that you come really close to but will never cross. So as a friend zone, you're really close to that person, but you will not cross a line with them because you're just friends. So in this example on the left side, a lot of it's been done for you. So my a value, remember it's a times b to the x. So a is 3, my y-intercept is 0, 3. I can see that from the graph, so if I don't remember a and my y-intercept are attached, then I can look at the graph. B is 2 because B is with X. This we have not answered. Is this increasing or decreasing? Well, remember we read graphs from left to right, so if you were riding up this on a bike, you would have to go up at the end. Domain has been listed for you. Domain for all exponentials is always all reals. Remember, we can write it like the double R, or you might also see it negative infinity less than X less than infinity. This will show up quite a few times on your test over 15, so make sure you're familiar with this. Now my range, it looks like my y's are going down to 0, but remember that friend zone is at 0, so I can't be at 0 because that's the friend zone. But I'm everything above 0, so y is greater than 0, and that asymptote is my friend zone. So wherever you cannot go is your asymptote. These two should be directly related. Range should be a greater than sign, asymptote should be an equal to sign, and these numbers should be the same because your range is everything above your friend zone and your asymptote is your friend zone. And then your initial value is where you started, which is also your a value, and then this asymptote is a horizontal line. Your asymptotes should always be horizontal with these because they're always going to go side to side. So if we look at the second example, my a value, it's a times b to the x, so my a value is an invisible 1. I can see from the a value or from the graph that my y-intercept is at 0, 1. My b value is 1/2. Because this is a fraction, it is a decreasing graph. As you read this from left to right, if you were on a bike, you would be skateboarding or biking down. Your domain is always going to be all reals. And then my range, this gets really close to 0 and is going up, but remember it does not equal 0 because we have that asymptoted friend zone there. Okay. My initial value, a is at 1, and the asymptote is always horizontal no matter what exponential problem you're looking at. So to finish this off, they've asked us to determine domain, range, and asymptote for each of the following. So domain is going to be all reals for all of these. Problem 1, my range, my lowest y's are at 0, so my asymptote is at 0. Problem 2, my y's are down at -4, so my asymptote is at -4. See how those are directly related. Same thing here. This one, my y's are at 2, so my asymptote is at 2. So again, directly related. Okay. So then when we're going back, they want us increasing or decreasing. 1, if we read left to right, is going down. 2, left to right, going down. 3, left to right, going up. So possible b values for all of these. To be decreasing, it would have to be less than 1. So maybe 1/2 or 1/3, and we're just guessing here. And then increasing has to be greater than 1. So maybe 2, you could put 1.5, you could put 17. Any of those that are bigger than 1 for increasing and less than 1 for decreasing. And then initial value is at 1. Y-intercept here is at, looks like 4. And y-intercept here is at 3. The last piece for these notes is to determine what type of function. So linear is a line. Some people call it linear. Quadratic looks like the U in the word quadratic, and then exponential. You just got another one. Sorry, but if you can figure out the other two, you can know exponential. So 2x is going to be linear because it has a plane normal x. X squared is quadratic. And then x in the exponent is exponential. Remember all three of these, if you're more familiar with graphs, you could plug all of those into y equals and see what's going on. 11, this one is a curved line, but it does not curve and come back up, so that's going to be exponential. 12 is a straight line, so linear or linear. And then 13 goes down but comes back up, so that would be quadratic. Remember, the U in quadratic goes down and comes back up. So if it looks like a U, then it's quadratic. If it looks like half of a U, like 11, then it's exponential.